Hello, I'm Michael Bunch. I'm the plant pathologist at the North Dakota State University Carrington Research Extension Center. I'd like to take this opportunity to share with you what we have learned about the impact of crop rotation interval on the management of Aphanomyces and Fusarium root rots on field peas. I'd like to start by thanking my staff, Aaron Fowles, Sharon Collis, Jesse Hafner, Gabby Henson, also our student workers. These staff put in significant hours. They work very hard and they're very dedicated, and this work is only possible because of their dedication. I'd also like to sincerely thank the funding agencies, the North Dakota Pulse Growers Association, and two different agencies administered by the North Dakota Department of Agriculture, the North Dakota Pesticide Harmonization and Registration Board, and the USDA Specialty Crop Block Grant Program. These three funding agencies have been responsible for funding this research, paying for the staff, paying for the supplies and the fuel and the other costs associated with executing these studies. I would also express my thanks to the private companies who do contract fungicide testing with us, because that contract testing is what gives us those additional resources that we need to be able to purchase the farm equipment that we utilize to execute these studies. I'd like to begin by giving you a quick overview. Fusarium root rot is this brownish, typically brownish to almost black discoloration of the epicotyl and taproot. Okay, it can be caused by multiple Fusarium species, and it's really a dark rot. Sometimes you'll see a reddish brown color, but typically it's in field peas. It's this brownish to brownish blackish color. Okay, Aphanomyces, on the other hand, causes a yellow-brown discoloration of the roots and the epicotyl. The epicotyl is that section between the point of seed attachment and the soil level. And what you'll notice with Aphanomyces is that it causes a shrinking of that epicotyl, okay, where it's no longer fleshy. And the other big thing with Aphanomyces is that you'll typically see a lot of the nodules are not active anymore, okay? And so, but anyhow, it's this yellow-brown discoloration. As the disease progresses, you'll have other microbes move into that, and it can get a little bit darker, okay? But again, it's the shrinking of the epicotyl. All right, Fusarium produces a microscopic structure called a chlamydospore, and the chlamydospore is a long-term resting structure. Aphanomyces creates another microscopic structure called an oospore, and this also is a long-term resting structure. And so both of these pathogens create microscopic structures to allow them to persist in the soil. Okay, and as such, it's always been a bit of a question how much crop rotation would help with these, because we know the pathogens can persist in the soil, but yet we also know that anytime a pathogen population builds up because of frequent cropping, if you drop back that cropping intensity, nature tends to come back to equilibrium, and a pathogen that's at very high levels will drop back. And so, at any rate, so it's been an open question how much crop rotation might help us with the Aphanomyces and Fusarium root rot complex. And we call it a complex because these two diseases are almost always occur together. I mean, some fields are going to have more Aphanomyces versus Fusarium. Others will have a bit more Fusarium versus Aphanomyces, but they occur together. Okay, and so it truly is a disease complex that occurs together and causes the disease syndrome, which ultimately is this wilting of the plant and premature death of the plant. All right, we did two sets of studies. What I'd like to talk about first are long-term crop rotation studies that we have been conducting in Carrington in east central North Dakota and in Hettinger in southwestern North Dakota since 2014. Okay, these are large plot studies, 30 by 60 foot at planting. We do only assess yield in the middle 20 feet of that 30-foot width, okay? Normal seeding rate and row spacing for peas. Now these are zero tillage studies. In Carrington, we started the zero tillage with the beginning of the study in 2014. And now that we're in 2025, we're in the, we're definitely a well-established no-till. Okay, now in Hettinger, on the other hand, that study started out as long-term no-till from the very beginning. Okay, now we do assess root rot at early to mid vegetative growth in Carrington, where the root rot pressure is very high, and at bloom initiation in Hettinger, where the root rot pressure has been lower. Okay. All right, let's start off with the results from Hettinger. Now, this study was purposefully placed on a site that had no prior history of pea and lentil production. We wanted to know, how does crop rotation interval impact the buildup of root rot in a site that's never seen peas or lentils before? Okay, and I say lentils as well because the Aphanomyces and Fusarium root rots share a host range. So basically they impact both peas and lentils about equivalently. Okay. But anyhow, so this is a site where we should have had no root rot coming in, okay? And indeed, in 2014, I mean, it was just trace levels of root rot. Okay, we did manage to isolate Aphanomyces in that first year in 2014, but the root rot severity was just at trace levels. And what that does mean is that even a site that's never seen peas before, it very likely has some trace levels of Aphanomyces. Okay, at least here in the Northern Plains. Okay, in 2018, which was year 4 of the study, we were able to compare a 4-year and 2-year rotation. You notice that there was hardly any root rot at that point. 2020, year 6 of the study, we were able to compare a 3-year and 6-year rotation. What you can see is that we clearly had less root rot in the 6-year versus the 3-year. But at that point, the root rot severity was not high enough to be impacting the yield. Okay, in 2022, now the root rot severity was at much higher levels, but there was no differentiation between a 2- and 4-year rotation, i.e. the 4-year rotation wasn't long enough to impact that root rot severity. All right, what you'll notice is that if you look at those data in that 2-year rotation, we went from a 2% root rot severity to 36% to 79% in those 2-year intervals. Okay, always assessed at a very similar growth stage or early bloom. And if you plot the severity versus the year, you'll see that it's well correlated. I know it's a small number of data points, but it does correspond to what we would expect, in that the root rot severity starts to really show up about the 4th time you grow peas. And that's what everyone always says. It's about the 4th time you grow peas in the field that you start to see the root rot usually. Okay, at least if you're getting decent amounts of rain. Okay, so but the results do suggest that the 6-year crop rotation may help reduce the buildup of root rot. So what about Carrington? Carrington, the study was purposely established on a site with a long history of field pea production and already severe Aphanomyces and Fusarium root rot pressure when we started the study in 2014. Okay, this was a field where we had a long history of foundation seed increase, and we came in here looking to see how we could manage the problem. Okay. And so in 2018, we're looking at a 4 versus 2-year rotation. 2022, again, a 4 versus 2-year rotation. What you'll notice here, in neither of those years does that 4-year rotation give us good enough management of the problem. So 3 years out of peas just isn't good enough as a standalone management tool by any means, okay? And interestingly, that flax rotation seems to be performing well with us. We'll have to see if that holds as we carry this study through completion, but it seemed to certainly not be deleterious, if anything a little bit helpful. Okay, now the 6 versus 3-year rotation, there what you can see is that 6-year rotation, now we're getting into the territory of yields where the peas kind of make some sense. But notice that we had to be 5 years out of peas to see that. Okay, but again, just like Hettinger, that 6-year rotation is helping us. And in this case, we're getting close to that 50 bushel yield, which is starting to get commercially acceptable in the Carrington area. So in Carrington in 2020 and 2022, we actually split those plots between non-treated seed and a fungicide seed treatment. Okay, and what we saw is that adding that fungicide seed treatment helped with yields. Okay, now Again, these are fields. This is a field with elevated Aphanomyces and Fusarium root rot pressure. What I would caution you on is that this seed treatment, in this case obvious from BSF, is a seed treatment has excellent efficacy against Pythium and Rhizoctonia, and some degree of efficacy against Fusarium, but it's not fantastic, and certainly zero efficacy against Aphanomyces. So when you're seeing this yield response, especially in 2020 when we planted particularly early, okay, you should immediately be thinking, well, what's the seed treatment helping with? And what I would offer you, based on our other work with the seed treatments in these fields, is that these fields with a Fusarium and Aphanomyces problem also have elevated Pythium and Rhizoctonia in many cases, and that's certainly the case in this field. All right, and so the seed treatment is primarily helping us with that, especially since in 2020 we planted particularly early, okay, when the soils were cold. All right, so in 2020, notice that seed treatment plus the 6-year rotation brought us really close to a 50 bushel yield, which is really pretty good in this field. And 2022, on the other hand, when we're only looking at a 2 versus 4-year rotation, notice that 4-year rotation is just not quite good enough, all right, even with the seed treatment. All right, so what I want you to look at now is, again, that root rot severity in the 2-year rotation. And notice how it jumps around from a 53% to a 26% to an 85%, okay, and again, this is in the exact same study with root rot assessed at a similar growth stage. So what's responsible for that? Well, if you look at this scatter plot, you'll see that I've plotted the root rot severity versus the soil temperature at planting. In this case, the metric that I'm using is the soil temperature day and night in the first 7 days after planting. And the reason why we use that average is because on the warm days, on the sunny days, the soil temperature is going to be a little bit warmer than on the cold days. If you look at the first 7 days after planting, it gives you a really good average of the actual average conditions that those seeds were exposed to as they were germinating, and it's also a metric that anyone can utilize to plan their planting, because if you know your current soil temperature and you know the forecast, you can target a specific soil temperature. Now look at where the root rot severity was the lowest. The root rot severity was the lowest when we were planting at about a 43 to 46 degree soil temperature in that, again, in that first 7 days after planting at this 2-inch seeding depth. Now that coincides perfectly with our planting date research. That shows that you need to be targeting about a 43 to 49 degree soil temperature to optimize field P agronomic performance under Aphanomyces root rot. So what this also means is that year that we assessed that 6-year rotation, really what we were looking at there was early planting plus 6-year rotation plus seed treatment, and those three together gave us pretty good results. Okay, but notice that each one of those is just giving you partial control. The early planting is helping you manage the Aphanomyces and Fusarium root rot complex by giving your peas a running start before the soils get warm enough for Aphanomyces and Fusarium to be significantly active, okay, and so that's the early planting. The 6-year rotation helps bring down your pathogen pressure a little bit, okay, and then the seed treatment helps protect against primarily the Pythium and Rhizoctonia that are active when you plant early. Okay, so notice that these are 3 different tools that added together give you a great result, but any one of them used on its own wouldn't give you a good enough result. Okay. So in conclusion, what we have learned from these long-term crop rotation studies thus far, and the studies are not complete yet, is that crop rotation interval appears to help with management of Aphanomyces and Fusarium root rot, but it looks like you need to be 5 years out of peas, you're on a 6-year crop rotation interval in order for crop rotation to be of a significant help. Okay, and even then you should only expect partial management, And really you need to combine crop rotation with other tools such as early planting and fungicide seed treatment to achieve satisfactory results. So what I've just shared with you is that what we have learned thus far in these long-term crop rotation studies that we're conducting in Carrington and Hettinger is that it looks like crop rotation interval can help us manage this root rot complex in peas. It looks like we might need to be at a 6-year crop rotation, i.e. 5 years out of peas, to see a significant bump from the crop rotation as a management tool. But it looks like it could help us. Now, we will be continuing those long-term studies through at minimum 2026, when all of those crop rotations will meet up, and we'll have field peas planted through the entire study, and we'll be able to compare a 6 versus 4 versus 3 versus 2-year rotation. Okay, but in the meantime, what I wanted to do was to evaluate this research question in another way. And so Carrington, as many of you know, has a long history of foundation seed increase in field peas. And as a result, many of our fields have significant Aphanomyces and Fusarium pressure. What we did was we went into 11 of these fields that have a long history of field pea production, and we established planting date studies in each of those 11 fields. Now, these fields differ in the interval since the last time peas were grown. And so we looked at the impact of planting date relative to the interval since the last time peas were grown. And within every planting date, we looked at 2 field pea varieties with or without a fungicide seed treatment. And we always looked at 4 planting dates. Well, all but one study in 2023 where we lost 1 planting date, but otherwise always 4 planting dates. Okay, we did everything we could to assess root rot at a consistent growth stage across every variety and every planting date. Okay, and assess wilt. So the percent of plants that are wilted due to severe root rot. Assess that wilt at a consistent growth stage across varieties and planting dates in every study. All right, so what I'd like to start with are the results from 2024. And the most helpful way to start is to discuss what pathogens were present. Okay, so we did diagnostic testing through the National Agriculture Genotyping Center. They have a DNA-based test that's very rigorous, and we sent in symptomatic roots, and they conducted the testing for us. And what you can see right away, so we have 4 different fields that had a 3 to 4 year crop rotation interval. Okay, we had 2 fields with a 5 to 6 year crop rotation interval, and then 5 fields with an 8 to 11 year crop rotation interval in our planting date studies in 2024. And what you can see immediately is that the Aphanomyces levels were very, very high. We did not detect Fusarium excisprum in any of these fields in 2024, and we did detect Fusarium avenaceum, which is a root rotter. Okay, but it was at much, much lower levels than the Aphanomyces. So what these diagnostic testing results suggest is that Aphanomyces was a very, very important contributor to the observed root rot, just like the symptoms would have indicated. Okay, now what you need to be aware of, even though the levels of Fusarium avenaceum are very low here, Fusarium avenaceum is not the only species of Fusarium that can contribute to that root rot. Okay, and we didn't test for the whole range of Fusarium species. Okay, and so this is only an incomplete snapshot of the Fusarium, the contribution of Fusarium to the observed root rot, but it does certainly indicate that Aphanomyces is an extraordinarily important component of the observed root rot, just like the symptoms would suggest. So what about those symptoms? What we looked at on 2 of the fields were some very detailed, we took some very detailed notes on the symptoms. And these 2 fields had 6 different field pea varieties, not just 2, and across all 4 planting dates. Okay, so 6 varieties across all 4 planting dates. And in planting dates 1, 2, and 3, we assessed the symptoms by disease. So this Fusarium and Aphanomyces root rot complex is composed of an Aphanomyces root rot, a Fusarium root rot, and can also be composed of a Fusarium oxysporum wilt. And these are specific strains of Fusarium oxysporum that actually colonize the vascular tissues, the water-conducting cells of the plant, and cause the water-conducting cells to get plugged and the plant to wilt for that reason. Okay, and so if you have the vascular wilt, the Fusarium oxysporum vascular wilt, you'll see that vascular necrosis in the epicaudal, particularly the upper epicaudal. So we looked at the upper epicaudal and assessed the percent of plants that exhibited that brick red, that reddish brown discoloration of the vascular tissues. Okay, and we also did a microbiological assay where we actually plated out those stem sections and looked to see whether we could get the Fusarium to grow from the ends of the stem sections. So when I say plated out, we took stem sections, we surface sterilized them, i.e. we gave them a little bath in ethanol and dilute Clorox to kill off the microbes on the surface, and then rinsed it in sterile water and then plated it onto microbiological media. In this case, media that is mostly specific to Fusarium. It will allow a few other things to grow, but mostly just Fusarium. And then we look to see what proportion of those epicaudal sections would have the Fusarium growing from the ends. And we were careful to take epicaudal sections that didn't have abundant necrosis on the surface. Okay, try to get clean epicaudals to do this with. And what you can see on both of these assays is that the incidence of either isolating Fusarium oxysporum from the stem ends or the incidence of seeing the symptoms characteristic of Fusarium oxysporum wilt was very low. That means this suggests that Fusarium oxysporum wilt is not a significant contributor to the observed symptoms. Now, what you'll see with the Fusarium root rot severity is that it was at moderate levels, okay, and that the symptoms characteristic of Aphanomyces root rot were at very high levels. Now, this coincides with what we just saw in the diagnostic testing, okay, in that the diagnostic testing said that we had lots of Aphanomyces, moderate levels of Fusarium root rot, and it didn't detect Fusarium oxysporum at all. All right, so again, the symptoms are very, very, very consistent with what we saw with the diagnostic testing. Okay, so what these results suggest is that these fields were conducted in fields with very high Aphanomyces pressure and moderate Fusarium root rot pressure and very low levels of Fusarium oxysporum wilt. All right, so what did we see? Okay, and so what I have is combined analysis here, and what you have here is the planting date on the left, and on the top you see your crop rotation interval. Okay, and so this is combined analysis across multiple studies. Okay, and so you're looking at 4 fields that had a 3 to 4 year rotation, 2 fields with a 5 to 6 year rotation, and 5 fields with an 8 to 11 year rotation. And this is the average across all of those. Okay, and what you can see immediately if you look at this is that the root rot severity decreased as you increased your crop rotation interval. Okay, so what this suggests is that, again, crop rotation interval can help manage this root rot complex. Okay, how about the wilted plants? And this is what everyone cares about. This is the premature mortality of the peas that causes the peas not to fill out the pods and causes the yield loss, right? And so what you can see here immediately, the same story. It doesn't matter the planting date. You have less wilt as your crop rotation interval improves. Okay, so crop rotation interval helped us. A longer crop rotation interval helped us. And all that, of course, translated into yield as you would expect if you look all the way across the planting dates, you'll see that that broadest crop rotation interval had the highest yields. But you'll notice something curious. Notice in that that tight crop rotation interval, just 2 to 3 years out of peas, if you plant it early, those yields are pretty good, right? The problem is if you couldn't plant early, because all the other planting dates, you'll see a significant penalty to that tight crop rotation interval. And so what these results suggest is that if you're on a tighter crop rotation interval, you might be able to still get profitable peas if you get that planting date right. Okay, and again, early planting in this case corresponded to about 44 to 46 degree Fahrenheit soils at seeding depth, which is right in our optimal that we've discussed before. So let's look at this in great detail. Okay, and here are the same results again, but now without any reduced color, just if you want to look at it in greater detail. All right, so okay, looking at root rot severity. Now, what you see here is a scatter plot that shows the results from individual studies. It shows you the consistency of the results, okay? And then you see a bar graph that gives you the average across those studies. And what you see now is, okay, we have 3 planting dates, and you'll see within each of these, you can see the performance of the variety with and without a seed treatment. Now, the only reason why you only have 3 planting dates on this data is because we did not get a chance to assess root rot in the 4th planting date in 2024, just because of labor constraints. Okay, so we only looked at root rot in 3 planting dates. The rest of the data will be at 4 planting dates. But what you can see right away is that that 3-year rotation had worse root rot severity than the 8 to 11-year rotation, just like we saw before. But notice how the penalty you get to late planting here. I mean, the root rot severity is off the charts if you didn't get in early. And you're looking at only a slightly over 2-week delay here. Okay, but yet if you're on that broader crop rotation interval, notice that it's a little more forgiving without late planting. Okay, and so here you are comparing that 3 to 4 year rotation versus a 5 to 6 year rotation. You see the exact same story. Okay, and so essentially, again, you know, you can get away with that tight crop rotation if you plant at the optimal soil temperature, but if you can't get in at that soil temperature, that tight crop rotation could really hurt you. That's what this suggests. Let's look at the wilt data. Now, of course, we have data from all 4 planting dates. Okay, and here you have that 3 to 4 year crop rotation versus the 8 to 11. Notice that, of course, you have lower wilt with that 8 to 11 year rotation no matter what. But again, it's just like we saw with the root rot data. You'll see that that penalty to applying to planting late is much higher with the tight crop rotation. The other thing is you'll notice that in that tight crop rotation, we only had acceptable levels of wilt when we planted Julius, AAC Julius. Now, AAC Julius is more tolerant of this root rot complex than AAC Prophet. And that's something we learned by accident as we were running these studies. Okay, but what you can see is that if you had that tight crop rotation interval, you only achieve an incidence of wilt below 10% at late pod fill if you're planting that tolerant variety with a seed treatment. Okay, and you're planting it early. All right, and so if, on the other hand, you had a wide crop rotation interval, you could get away with planting the susceptible variety and still get a pretty decent level, reasonably acceptable level of wilt. And the other thing is if you had that, notice that as you look at that 8 to 11 year rotation, notice how that tolerant variety with that later planting date's working okay. All right, so you know, what it basically says is that 8 to 11 year rotation may give us some flexibility on variety selection, planting early, or if you have a tolerant variety, give us a little bit of flexibility on planting date. On the other hand, if you need to go with a tight crop rotation, you better be really careful with your variety selection and get it in early. What about that 3 to 4 year rotation versus the 5 to 6? Notice the exact same story. And just like the root rot data, it suggests that 5 to 6 year rotation might just do the trick for us. We don't necessarily have to wait till 8 to 11 years. What about yield? Okay, what do you see here? You see that 3 to 4 year rotation. You're doing okay on yield if you get it in early and you plant a tolerant variety. Okay, as you go to a broader rotation, the penalty to planting later has dropped. Okay, so there's still a penalty to planting later, but it's not nearly as severe. Okay, and so the same story we just saw with the wilt. Okay, so if you're on a tight crop rotation, you really need to have that tolerant variety and get it in early. If you got a broader crop rotation, you have a little more flexibility with your variety selection planting early. And if you get delayed, that tolerant variety may still perform reasonably well, whereas it won't on a tight crop rotation. Here we are looking at the 3 to 4 year rotation versus the 5 to 6, and notice the exact same story. Okay, so in conclusion, what these studies suggest is that when the crop rotation is tight, field P variety selection and planting date are critically important for achieving commercially acceptable field P yields. Okay, a minimum 5 to 6 year rotation may confirm flexibility with field P variety selection when planting early. Likewise, a minimum 5 to 6 year crop rotation interval may confer moderate flexibility with planting date. Okay, so you can get away with planting 2 weeks after you hit that perfect soil temperature for an Aphanomyces field if you have a long crop rotation interval. Okay, now you're still going to suffer yield loss, it's just not going to be catastrophic. But then it becomes very important to have that tolerant variety. Okay, so what, in conclusion, have we learned here? It looks like crop rotation interval really helps us, but mostly it helps us by giving us more flexibility relative to planting date or field P variety selection. It looks like we might be able to get away with a tight crop rotation interval if we're very judicious on what variety we plant and we make sure we get it in at the optimal soil temperature. So let's look at our results from 2023. Okay, we conducted these studies again across 11 fields with 4 planting dates. And almost all these fields are exactly the same. We just had a different spot in the fields where we ran the studies. Okay, but otherwise the fields are the same. There are a couple changes though. Okay, basically 10 of the fields are the same as the year before, and one of them is different. Okay. But again, we did not go P's on P's ever. We just moved to a different spot in the fields. What do you see right away here? Same story as the other, as in 2024, in that Aphanomyces is at high levels consistently, except for a couple fields where we didn't detect it. Okay, but otherwise, Aphanomyces is extremely high levels. In this case, we had detected Fusarium exciprum sometimes. But notice that we detected Fusarium exciprum from Julius. Now, Julius was the variety that was performing better, okay? And so what that means is that there's no way that Julius is more susceptible to Fusarium exciprum wilt, right? If anything, it's more susceptible. Of course, Fusarium exciprum can also be, when you're testing positive for Fusarium exciprum, it could be for a root rotting Fusarium exciprum or the wilt. But by all means, Julius is more susceptible to Fusarium exciprum is what these data suggest, which means that the difference in the performance of those two varieties is not because it has better resistance to Fusarium exciprum, okay? And what we can conclude is that the better performance of Julius is because it has better tolerance to the broad root rot complex, okay? In this case, we did not detect Fusarium avenation, but again, remember that Fusarium root rot can be caused by multiple species of Fusarium, and a negative for Fusarium avenation or a negative for Fusarium exciprum does not mean that Fusarium root rot did not contribute. We did not test we did not do diagnostic testing for all the species of Fusarium that can contribute to this root rot complex. You should assume on the basis of this, though, that Aphanomyces appears to be the predominant pathogen impacting the peas in these fields, just like we saw in 2024. Fusarium root rot is likely just a moderate contributor, okay? And Fusarium excisporum wilt appeared to not be a significant factor. All right, so what did we learn? Now, first off, in these fields, look at these planting dates. 2023 was a very difficult spring. It was very, very cold and wet early, and we couldn't get in the fields. By the time we finally could get into the fields, you notice the first planting date is May 22nd, very, very late. Not only did it dry out, but it got really hot. Okay, so we went from extremely cold and wet and unable to plant anything to blazingly hot almost immediately. All right, and anyhow, so all the planting dates are in late, just the way it was that year. Okay, all right, root rot severity. You can see that the root rot severity jumps around by planting date a little bit. That has everything to do with just how hot it was in the first 3 weeks after planting until between planting and when we assess root rot. Okay, and 3 to 4 weeks or so, but what you can see is that crop rotation interval mattered. Okay, so the shorter the crop rotation interval, the more the root rot you had. Okay, how about wilted plants? Same story. Okay, the incidence of wilted plants was clearly influenced by the crop rotation interval. So the longer crop rotation interval had less wilt. And yield, well, the yield followed. All right, and so with the better crop rotation interval, you had higher yield potential. That said, the 5 to 7 years, 7-year crop rotation appeared to be enough. Okay, you didn't get much more gain by waiting longer in terms of yield. All right, so here are these same data, but now with nothing shaded in case you want to look at it in greater detail. All right, so now let's look at the scatter plots. So now what we're doing is we're looking at the 4 planting dates, and we're looking at the performance of the varieties with and without seed treatment. What you can see right away is that 3 to 4 year rotation gave you more root rot than the 8 to 10, just like we saw, and that increase in root rot was consistent across planting dates and consistent across varieties and seed treatments. Same thing as you compare the 3 to 4 year rotation to the 5 to 7. Okay, again, the tighter crop rotation interval resulted in higher root rot severity, and it didn't matter what field pea variety you were planting or whether you had a seed treatment or not. Okay. All right, so what about incidence of wilt symptoms at late pod fill, mid to late pod fill? What you can see here is that crop rotation interval clearly impacted it, the incidence of wilt, and made it worse when the crop rotation interval was tight, and that was consistent irrespective of field pea variety selection or seed treatment. That said, variety selection was critically important in determining your wilt severity. Okay. Now, if you notice something here that's really curious, notice that treated seed actually has slightly higher incidence of wilt than the untreated seed. Now, I've never seen this before, but we saw this very consistently across the studies, and actually, if you look at the separate presentation I gave on fungicide seed treatment, you'll see that it got worse the warmer the soils were. Okay, and so I don't know if we'd see this again. It's very rare that we see soil temperatures this warm during planting season. We only saw it in 2023 because it was unusually hot with highs in the 90s as we were planting these studies. So it's unusual to see soil temperatures that warm. And the other thing is I don't know if we'd see it with other seed treatments too. Okay, we only tested obvious that year. We didn't test others. So these are soil temperatures that are well outside the range of what we normally would plant peas at. I wouldn't be too concerned about this because we plant our peas earlier, especially in these fields with a significant Aphanomyces and Visceral root rot, but just note that, okay? Under these very warm soils, we actually saw a deleterious impact of the fungicide seed treatment. All right, and so instance of wilt, again, you notice that that 5 to 7 year rotation is a lot better than the 3 to 4 year rotation, and that's the same across all the planting dates and all the varieties and seed treatments. Okay, so what about yield? Again, with yield, what you can see here is that crop rotation interval mattered. Now, let's look at the yields on that 3 to 4 year rotation. You can see that if you went in with the earlier planting, that the Julius peas, i.e. the more tolerant variety, actually performed quite similarly in that 3 to 4 year rotation versus the 8 to 10. I mean, it's a little bit lower with the 3 to 4 year rotation, but with the tolerant variety, the difference is small. Okay, so this is similar to what we saw in 2023. If you're on that tighter crop rotation interval, it becomes really important to select the more tolerant variety. Okay, you notice that the penalty, the yield penalty associated with planting the susceptible variety, profit, is much higher in the tight crop rotation than the wide crop rotation. Okay, so the take home here, same as in 2024. If you have a tight crop rotation interval, it's really important to plant a field pea variety that has some tolerance to Aphanomyces. Okay, and if you have a wider crop rotation interval, you're going to have a little bit more flexibility on your field pea variety selection. Still, the tolerant variety is going to perform better, but the penalty to getting the variety wrong is going to be much lower. So what did we see here with a 3 to 4 year rotation versus the 5 to 7? It's the exact same story. Okay, so again, you're going to have more flexibility on your variety selection with a broader crop rotation interval. But still, if you have a Aphanomyces pressure, that tolerant variety is always going to pay. It's just a question of how much a penalty do you have to planting the more susceptible one. Okay, so what did we learn from these studies conducted in 2023? What we learned is that when early planting is not possible, like we couldn't plant early in 2023, okay? Losses to Aphanomyces root rot can be sharply mitigated through crop rotation and field pea variety selection. And if you don't have the option of crop rotation, of extending your crop rotation interval, it's just not economically feasible for you, that field pea variety selection becomes critically important. Now, there's one more way to look at these results. All of these planting date studies were conducted on fields that are utilized for foundation seed increase, like I just said. Okay. Now, some of the planting date studies were conducted on fields predominantly used for foundation seed increase and occasionally utilized for small plot research. Now, 2 of these fields had the same field pea crop rotation history across the entire field except for a moderate-sized footprint within the field, where we had grown small plots, peas in small plot studies one year. Okay, and in these fields, what we did was we conducted 2 different planting date studies. One where on top of the footprint of where we had that small plot field pea study several years back, and another one on the rest of the field. And so what you can see is that what we ended up with was both of these studies had the exact same general cropping history, except one of them had peas grown just one more time. And in this case, it would have been the difference between the last time peas were grown. Okay, and so let's look at the results. Okay, So here you have a field that we call field 18, okay? And what you can see is that we, on the left side, we planted on top of the footprint of a previous small plot study, okay, where we had grown peas. And in this case, we're just 2 to 3 years out of peas, okay? And on the right side of the slide, you will see studies that conducted on the rest of the field. In that case, it's 7 to 8 years out of peas. So these studies differ only in terms of crop rotation history. They differ only in that the studies on the left had peas one more time, in this case 2 to 3 years ago, and the other part did not get peas 2 to 3 years ago and hadn't seen peas since that whole field was planted to peas 7 to 8 years prior. So what you have here is a difference in crop rotation interval, but otherwise on a background that's virtually identical, okay? And what you can see right away is that that longer crop rotation interval gave us a 25% reduction in root rot, a 38% reduction in wilt, and a 47% increase in yield. And you'll notice that field pea variety selection was critical. Again, Julius, which has greater tolerance against the Phantomyces root rot, performed much better. So we have another field where we did this. This is a field we call Q9E. Now, we ran studies on the western part of the field where we had some small plot studies back in 2018, okay? And then we ran studies on the eastern part of the field that hadn't seen peas since the last time the entire field was cropped to peas in 2015. And what you see, the same story as in field 18, okay? That longer crop rotation interval helped us a lot with our root rot management. And again, variety selection helped us too, okay? So what do we learn from this? What we learn again is that crop rotation interval helps us, okay? So it's a tool in our toolbox, but it's only going to give us partial control, and we need to combine it with other tools, okay? Because you know, if you looked at that, even with a long crop rotation interval, you know, field pea variety selection really mattered. Okay, so let's touch on this one more time, okay? So we ran in 2 fields in Carrington, really extensive studies in 2024. And these are studies with 4 planting dates, 6 varieties, and each of these varieties with 5 seed treatments. So 4 seed treatments versus non-treated control, okay? And this study right here had a tight crop rotation interval. See, a 3-year crop rotation, just 2 years out of peas. And what do you see here? You see that if we went in early, notice the soil temperature, 45.2 degrees Fahrenheit, average day and night in the 7 days after planting. You can see if we went in early, we were able to get really good yields if we were careful with our variety selection, okay? But notice we got really good yields on the top 4 varieties. So we actually had fairly good flexibility. But notice also the incredible response we saw to a fungicide seed treatment with that early planting. And then look at that next planting date, which is just 2.5 weeks later. Okay, look at the huge drop-offs in yields. Okay, in the most tolerant variety, you're looking at yields that drop by at least 1/3. Okay, and in the rest of the varieties, you have yields that are going in half or worse. Okay. I mean, goodness, look at the reduction in yield with cat porn. You have a 2/3 reduction in yield. Okay, the reduction in yield with profit, you have 75% reduction in yield. Okay, and so what you can see here is that with that tight crop rotation interval, we achieved really great yields with careful variety selection and early planting and fungicide seed treatment. But the penalty to planting late was very high, and we had to be careful with our variety selection. Okay. Now let's look at another field where we conducted this. This was a 9-year crop rotation, so 8 years out of peas. Now, what you'll notice here is that now we had a bit more flexibility on our field pea variety selection, at least in terms of yield. The penalty to planting profit early was not quite as extreme, okay, as in the other study. And now if you look at the difference between planting date 1 and 2, you'll see, yeah, there's a big drop off in yield, but it's not as extreme as we saw with that tighter crop rotation interval. Okay, so this really drives home the point that anytime you're under Aphanomyces and Fusarium root rot pressure, planting date matters, and it looks like variety selection really matters. Crop rotation interval helps you as well. You'll notice that the overall wilt incidence in this study is way lower than the other one. Okay, but you know, it's just one more tool in our toolbox, the crop rotation interval. Okay, and if you end up having to do a tighter crop rotation, you need to be just more judicious on your variety selection and more conscientious about planting early, because the penalty to getting both of those wrong is going to be much higher if your crop rotation is tight and you have the Aphanomyces pressure. So what we have learned from these studies is that crop rotation does help manage Aphanomyces and Fusarium root rots in field peas. However, it only gives you partial management of the root rot complex. You really, in order to achieve satisfactory management of Aphanomyces and Fusarium root rots, you need to combine multiple tools. Field pea variety selection, early planting, targeting that 43 to 49 degree soil temperature, average day and night at the seeding depth in the first 7 days after planting. Okay, and you can target that again based on the weather forecast and the current soil temperature. Okay, so field pea variety selection and early planting are very, very important tools. Crop rotation also helps, but on its own is not enough. Now, with that early planting, we typically see elevated Pythium and Rhizoctonia pressure. And in order to manage that, then you add that fungicide seed treatment. And that's why the fungicide seed treatment helps us. Okay? And so you add the fungicide seed treatment to take care of the Pythium and Rhizoctonia that come with planting early. You plant early because it gives your peas a head start before the soil is warm up enough for Aphanomyces and Fusarium to get significantly active. Okay, and if you can do that longer crop rotation interval, you're going to reduce your overall Aphanomyces and Fusarium pressure. Now, if you have a tight crop rotation interval, it appears that field pea variety selection becomes absolutely critical. Okay, with a huge penalty to getting your variety selection wrong. Okay, and likewise, if you have a tight crop rotation interval, the planting date becomes absolutely critical. As you move to a broader crop rotation interval, you get a little bit more flexibility on those two parameters, but not lots of flexibility, just a little bit more. And so, again, the conclusion here is that successful management of this complex may be possible by stacking multiple tools. I want to close, though, by giving you a warning. These data have been generated primarily in Carrington, okay? And we need to see these results replicated across multiple locations before I have confidence in them, especially the field pea variety selection impacts that we've observed. Okay, every field and every farm is going to differ in the mixture of the pathogens contributing to this root rot complex. Okay, so the strains of Aphanomyces, the species of Fusarium, and the relative importance of Aphanomyces versus Fusarium can differ across farms and fields. I need to see the replicability of these results at on-farm sites before I have confidence in them working across a broad geographic area. At this point, I know this works in Carrington. I know I'll see the same thing if I test it again in Carrington. I don't know that I'll see the same thing going to on-farm sites. And so in 2025, we are going to be conducting on-farm studies. And these will be large strip studies to evaluate the replicability of these results across on-farm sites. And at the conclusion of the 2025 year, I will have much greater confidence in the replicability of these results across fields and across farms across our region. I'd like to close by giving very sincere thanks to my staff and also to John Rickardson, the agronomist in Hettinger, who is conducting that long-term crop rotation study at that location, and also thanking again our funding agencies and reminding you that these are your checkoff dollars that have funded this. So thank you to each of you who has contributed towards this research with your checkoff dollars. Thank you, and thank you for your time.